Okay, welcome to this first video on slope and y-intercept. Some things to define first. When you look at these three lines, what do you notice is the biggest difference between them? Well, when I look at them, it looks like it has to do with the slantiness of the line. How slanted is the line? Okay, well, the slantiness of a line, we call that slope. Slope is actually a measure of how slanted the line is. Okay, so we've got to define some terms here. The first thing is positive zero or negative slope. So this example on the left, we call that a positive slope. And the way I keep that straight is, in most of the world, when we read a book, we read from left to right. So if you think about the direction that you read, as you go on the direction that you read, if the line is going up as you go in that direction, then we call that a positive slope. Okay, so positive slope lines go from lower on the left side to larger on the right side. Okay, the opposite is true for a negative slope. A negative slope, if you go the direction we read from left to right, this line goes down as we go that direction, and so we call that a negative slope. Okay, we have to define it some way. This is the way it's defined. Positive slopes increase from left to right, and negative slopes decrease from left to right. And then if we have a line that doesn't change it at all, it's not slanted at all, it doesn't change as I go from left to right, we call that a zero slope. So that would be the third case. Okay, so there's some definitions here. Now in general, right, the larger the measure of the slope, the more slanted it would be. Since zero is flat, then the bigger positive number we get, the more it deviates from flat. Okay, so steeper lines have larger numbers, and less steep lines have smaller numbers. Okay, how do we actually measure slope? Let's look at some specific examples. There's a lot of ways to define slope. This is the way I think of it. I think of it as slope is a fraction, and the top of the fraction is the distance in the vertical direction, the amount that we go up or down, and then on the bottom of the fraction we divide by the distance to the right. Since I'm always thinking in the direction that I read from left to right, the bottom number is always positive. It's the distance we go to the right. But the top number might be positive if I'm going up to create a positive slope, or it might be negative if I'm going down. So this example on the left, to find the slope, what you need to do is find 2 points on the line, and you can pick any 2 points that are convenient. I've got 2 of them marked here that are right at intersections on the grid. And then what I need to do is I need to figure out, as I go from the left point to the right point, how far up or down am I going? Well, the first thing is I'm going 1, 2, 3 units up. 3 units up, and then I go 1 unit to the right. Right? I'm going 3 units up and 1 to the right. And that means that the slope of this line is the 3 units up divided by the 1 unit to the right. Right? The top number is how far up or down I go, and the bottom number is how far to the right I go. Right? So 3 units up for every 1 unit to the right. Okay, so we would say the slope of this line is 3 over 1, or you could even simplify it to just the slope is 3. Okay? All right, in the right example, we've got 2 points here, right? And here, as I go from the left point to the right point, it looks like I have to first go down 1 unit. So in the negative direction, negative 1 unit down, okay? 1 unit down, and then I'm going 2 units to the right, right? So that means the slope here is going to be negative 1 over 2, right? Because it's 1 unit down, and it's 2 units to the right. Okay, and a slope is the amount that we go up or down divided by the amount to the right. So I think of that as, since it's in the downward direction, there's a negative 1, and the slope here would be negative, right? Slope is negative 1/2. Okay, and you can kind of see that the number 3, which was larger than 1/2, that's quite a bit steeper than the 1/2 is in the other direction, right? Positive on the left here, negative example on the right, and the one on the left is steeper, so its slope number, the measure of the slope, is larger. All right, we could spend gobs of time on slope. I know in Algebra 1-2 we spend weeks talking about slope, but we're going to just stick with the main points in this video. I will mention that there's a lot of different ways that different books and teachers use to describe this concept of slope, right? I like the idea of it being a distance up or down divided by a distance to the right. Some people talk about that as a change in y divided by a change in x. That's a great way to talk about it. Some people refer to it as rise over run, since rise is an upward or downward direction, right? And then run is kind of a direction away from you in the horizontal direction. We're going to talk in one of the other videos about formulas, about the slope formula, which says it's the change in y, which is y2 minus y1, divided by the change in x, which is x2 minus x1. We'll cover that in more detail in the formula video, right? And this is important too, that the slope is also can be considered a rate. For example, something like miles per hour. That's a fraction. It's an amount of miles divided by an amount of hours, so that's also a slope in some sense. Okay, for computing it, we're going to focus mainly on that top definition, distance up or down divided by distance to the right. Okay, so let's say I wanted to find the slope of this line right here. Okay, I've got 2 points, right? What I could do is figure out how far in one direction, how far in the other. It looks like I've got 2 units in that direction, 1 in this direction, and since I'm going down, I make that negative, and so therefore the slope is the up or down number divided by the other number, and simplify if possible. So slope would be -2 for this example. Okay, maybe try this one. Pause the video, see what you come up with for slope. Okay, let's see. As far as up or down goes, let's see. First of all, I've got to go, let's see. I'm going to go up 1, 2, 3 units, it looks like. So up 3 units, and then 1, 2, 3, 4, 5 units this way. So it looks like I'm going to go up 3, and then over 5. So the slope here would be 3/5. 3/5. It's positive. It goes from lower left to upper right, and fairly gentle, up 3 for every 5 that I go over. Here's another example. So this one's a little bit different, right? How far up do I go? Well, the amount that I go up is 0, right? I don't go up at all. I only go 1, 2, 3, 4 units to the right. So that would be 0 over 4, or a slope of 0. And that matches what we said in the beginning. We said that horizontal lines have 0 slope because there's no change, there's no slantiness at all. But you can still use the definition, up 0, 4 to the right. What about a vertical line? This is an unusual case, right? We would say that we go, in this case, up 1, 2, 3, 4. We'd go up 4. So let's try to use our definition. We would go up 4, but we would go none to the right, 0 to the right. So the slope here would be 4 divided by 0. Wow. That's undefined, right? We're not allowed to have a fraction with a 0 on the bottom, so we would say that the slope here is undefined. Slope is undefined. So that's kind of a very special case. If it's exactly vertical, then the line has no slope, or the slope is undefined, because we can't come up with a numerical measure for that case. Okay, so one last topic here. This graph represents the distance traveled by a car versus time. Okay, what is the rate in the speed in miles per hour that this car was traveling? Well, in a way, remember I said rate is like a slope. So let's take a couple of points that are on this graph. This point is 0, 0, right? And the next intersection I see is up here with the grid. So it looks like, let's see, well, how far up do I go? I go up 90, right, for every 2 hours. This is actually now 90 miles. I go up 90 miles for every 2 hours that I travel, right? So the slope of this curve is the amount that we go up, 90, which is in miles, and then that's divided by 2 hours, right? And so 90 divided by 2, right, the slope is 45, and that's miles divided by hours, which is another way to say that is 45 miles per hour. Right? So if we travel 90 minutes in 2 hours, then that means we're traveling, and we're traveling steadily, so it's a line, then that means we're traveling 45 miles for each of those hours, or 45 miles per hour. So 45 miles per hour represents a slope of this line. Okay? So that's what I mean by slope can relate to the idea of rate. Okay, we're going to go into more detail on slope in the next video.